Resilient sites, conservation priorities in the face of climate change. About resilient sites and why they may be critical to preserving biodiversity in the next century. According to an article by Peter J. Edwards and Cyrus Abavardi of the Geobotanical Institute in Switzerland, preserving biodiversity or variety of life in an area is important not only from a moral standpoint, but also from an economic standpoint. As problems of environmental change become more evident, we increasingly realize how much we depend on wildlife for a wide range of so-called ecosystem services. These services are split into 4 categories, which include supporting services, in which ecosystems provide habitats for species and help maintain genetic diversity, provisioning services, in which ecosystems provide food, raw materials, fresh water, and medicinal resources, regulating services, include regulation of climate, water, and diseases, and finally cultural services, in which nature provides recreation, tourism, inspiration, and spiritual experiences. Economic analysis can be useful in strengthening the case for conservation. Such analysis can demonstrate the potentially high economic value of wildlife and reveal more clearly the economic and social pressures which threaten it. This biodiversity that is so essential to human life will be affected in many ways by climate change. According to the UN's Global Diversity Outlook 3, which is a summary of climate change's impact on biodiversity, climate change is already having an impact on biodiversity and is projected to become a progressively more significant threat in the coming decades. Loss of Arctic sea ice threatens biodiversity across an entire biome and beyond. The related pressure of ocean acidification, resulting from higher concentrations of carbon dioxide in the atmosphere, is also already being observed. Ecosystems are already showing negative impacts under current levels of climate change, which is modest compared to future projected changes. In addition to warming temperatures, more frequent extreme weather events and changing patterns of rainfall and drought can be expected to have significant impacts on biodiversity. So what can conservationists do to preserve biodiversity in the face of a changing climate? This article from the Nature Conservancy, or TNC, tries to give one solution. All this change raises a troubling question for the Conservancy. Even if it has set aside land with the highest levels of plant and animal biodiversity today, how can it guarantee that such a rich ecological community will remain there a century from now? Mark Anderson, Director of Conservation Science for TNC in the eastern U.S., plotted the number of plant and animal species against different environmental features. One factor stood above the rest: geology. His research found that states with a greater variety of bedrock types hosted greater biological diversity. He said, "Climate might change the details of which species are in a particular region, but what's really driving the overall number of species is the number of different environments they have," he says. "If we want to conserve all the diversity in the Northeast in a continually changing climate, we have to make sure we have a conservation based strongly on geology." In order to take this concept of geology-based conservation and apply it to Minnesota, we use GIS to combine standard deviation of elevation, slope, and neighborhood varied aspect to isolate geologically resistant areas in Minnesota. Then we combine the resilient areas with friction of distance and connectivity to prioritize land for conservation in Minnesota. Here's the first GIS model we used. As you can see, we took data from 3 different categories: neighborhood STD, which is the standard deviation of all the elevations, slope, and neighborhood varied aspect, which is the variability in the facing of the land, so north, south, east, west. We combined these 3 factors to find our resilient sites, which are our geologically diverse sites that will be resistant to climate change. Here are the climate resilient sites that we found through our model in red. As you can see, along the Mississippi in the southern part of Minnesota, there are many climate resilient sites. Here is our second GIS model. We used previously shown resilient sites, here labeled as core reserves, combined with friction of distance, which is a measure of both proximity to these sites and difficulty moving through the area between these sites. We combine these and we get a map of our conservation priorities for Minnesota. Here's our conservation priority map based on resilience and connectivity. The high priority areas are shown in yellow, while low priority areas are shown in blue. As you can see, we have many geologically resistant sites in southern Minnesota along the Mississippi, as well as in northern Minnesota along Lake Superior. This information will be valuable to conservation groups in Minnesota that would like to protect areas that are more resistant to climate change and therefore protect biodiversity for the future.